Hello and welcome to our practice on spheres. We're going to get practice with spheres and pretty much composite figures at that. So it's kind of a combo practice lesson. We should know that the volume of a sphere is equal to 4/3 pi r cubed. So this first one, hopefully you have your packets out, turn to this page. For volume of spheres, the radius is obviously 5, so we could plug this in. Volume is equal to 4/3 pi times 5 cubed. 5 cubed is 125, and 3 doesn't go into 125, so we could write this as one long fraction. We could say 4 times 25 is 500 though. Pi is also part of that, and then your denominator only has a 3 involved. So 4 times pi times 125 is 500 pi. This is measured in feet, so this is feet cubed. And then if you do need to do this, if we do ask for an approximate answer, you could absolutely do this as well. Just throw it all into your calculator. 500 pi divided by 3. And you should get 523.60 feet cubed. So either one of these answers will work. That's perfectly fine, okay, depending on what the question asks for in terms of exact answer with pi or as an approximate answer rounding to the nearest whatever decimal. So here we have a hemisphere. Hemisphere is not 4/3 pi, but it's 2/3 pi. So we could do the volume is equal to, so the radius is 6, 2/3 pi times 6 cubed. 6 cubed is 216, and the nice part is 3 goes into 216, so this is going to work out very nicely. 216 divided by 3 multiplied by 2, or 2/3 of 216, should be equal to 144. So we end up with 144 pi. This is the exact answer. This is measured in inches cubed, and we are good to go. If you ask for the exact answer, you can go ahead and calculate that. I'm not going to do it here, especially since it turned out to be a whole number. All right, next one. Find the total volume of this composite figure. Now, this is where it does get fun because you have to create your own equations again. So the question then becomes, what do you see? Well, I for sure see, so let's call this total volume. Total volume is going to be equal to a volume of a hemisphere, because that's this part of it, plus the volume of a cylinder, so that's the middle part, plus the volume of a cone, which is the farthest right part. So we're going to have to calculate all of these things individually. So volume of a hemisphere, we know, is going to be equal to 2/3 pi times 4, for the radius, cubed. We know volume of a cylinder is equal to the area of the base, or the cylinder, pi r squared. So this is pi times 4, because that 4 transfers over. And then the height of this is 10, or the altitude is 10. Oops, this is pi r squared. And then the altitude of 10. Now the volume of a cone is equal to 1/3. Then we'll take the area of the base. Once again, it is pi times 4 squared, and then multiplied by the altitude. The altitude here is 3. Okay, so let's do this all individually. 4 cubed is 64. Multiply that by pi and 2/3, we end up getting 128 pi over 3. 4 squared, I should say, is 16. 16 times 10 is 160, so this is going to be 160 pi. And then here, let's start with the square. 4 squared, well, actually, let's do this. 1/3 and 3 actually cancel out because they are reciprocals, and when you multiply reciprocals, they equal to 1. So you end up here with just 16 pi. Okay, now this is the fun part. How do you add these together? Well, for sure you could add these two together because they are like terms. So these two together will be equal to 176 pi. But how do you add 128 pi over 3 with 176 pi? Well, you need to have like denominators. So what we need to do is we need to rewrite this so that it has a denominator of 3. So let's do that. Take that 176, multiply this by 3, and you'll get 528. So you have 528 pi in replacement of the 176. 528 pi over 3. Then you have the 128 pi over 3, and now you could add these because they are like denominators. This will be equal to, add the 128, 656 pi all over 3. This is measured in meters cubed. All right, so a few more problems. I'm just gonna set up some equations for you to actually solve. I'm gonna maybe do one more of these. Here we have a couple different shapes that we have to kind of manipulate the problems for. So find the volume of the space between the cone and the cylinder. So that is kind of like this area, this gap that we could solve for, okay? So how can we solve for that? Well, we definitely need the total volume would be equal to a combination of a cylinder, so the volume of a cylinder, and we are actually going to take away the cone, right? So we're going to subtract the volume of the cone. All right, so here we have there's some information here. The radius of the cylinder is equal to 10. The slant height is 13. And that's it. So the moment we have that, let's actually erase this so we could actually work with it. Let's take this 13 out. Let's put this here. We actually need to solve for the altitude. So we do some Pythagorean theorem work. We end up with a squared plus 10 squared is equal to 13 squared. We get a squared plus 100 is equal to 169. Subtract 100 from both sides, and you get a squared is equal to 69. You square root that, and that's not a perfect square, so you say a is equal to the root of 69. Okay, so now the volume is equal to, for the cylinder anyway, is equal to the area of the base times the height. Area of the base would be pi r squared. So this would be 10 square of pi times 10 squared times the altitude of root 69. We're then going to, we're going to do the volume of the cone. We would then take the area of the base, 1/3 area of the base. Once again, we're going to end up using that 10. So this is pi 10 squared times the root 169, or root 69. And then we calculate. Well, 10 squared is 100, so this is going to be 100 pi root 69, subtracted from almost the same thing, 100 pi root 69 over 3. So what we do here is this. Once again, we need like denominators to add this. Or if you're really, really thinking, you know that this is 1/3 of a whole, so this should be what's left over when you take it from a whole. It should be 2/3, but we'll get there. This would be, we need a like denominator of 3. So we multiply numerator and denominator by 3. So we end up getting 300 pi root 69 minus 100 pi root 69 over 3. And now we could actually subtract, because these are actually like denominators. They have the exact same two terms here. We are allowed to subtract these. What is 300 minus 100? Well, 300 minus 100 is 200. So we end up with 200 pi root 69 all over 3. Okay? This is measured in centimeters. So this is centimeters cubed. And this is your volume, the exact answer. If you do need an exact answer, you can throw it into your calculator, as I've said, but I'm not going to do that right now. All I'm going to do now is I'm going to write some equations for this to solve for just the volume here. All right, the volume here, let's create an equation. What do you see? Try one out, give this a shot, see if our equations match up. All right, here the total volume is going to be equal to the volume of the prism plus the volume of the pyramid. Okay, if you want to, hopefully you could do this on your own. I think you could handle this one with this equation, so I'm gonna move on to the next one. And this one you should actually be able to do because it is just a hexagonal pyramid. So you need the area of the base times it. So that's all I pretty much have. Be ready for some kind well, this is the last of our unit. So we just have a lab day, and then we're gonna go into review mode, and then we're gonna take this test. So if you have any questions, please bring them to class, and I'll see you in the next one. Bye.